I was staring at my phone this morning, just watching that little blue dot hover over my street on the map.
Right. It's totally mesmerizing.
It really is, and it hit me that I used to get so horribly lost before smartphones. We completely take for granted that our phones know exactly where we are, down to the meter.
Down to the meter, yeah.
But looking at the research for today's deep dive, the how behind that blue dot is, it's way more complex than just satellites looking down at us.
Oh, absolutely. It's an entire invisible science. And the sources we're diving into today call it geodesy.
Geodesy.
Yeah. The mission for this deep dive is to understand how we actually measure a planet that is constantly wobbling, shifting, and frankly, pretty lumpy.
Lumpy is a good word for it, because reading through these notes, geodesy isn't just basic map making.
No, not at all.
It's literally the science of measuring Earth's geometric shape, its orientation in space, and its gravity field. And the first thing that really jumped out at me is that the Earth is not a perfect sphere.
Right. Myth busted right out of the gate.
Yeah, it's an oblate spheroid.
Which is just a highly technical way of saying the planet is squashed at the poles and bulges out at the equator.
Because it's spinning.
Exactly. Isaac Newton actually predicted this back in the 17th century. He figured the centrifugal force from the spin would push the middle out.
But there was a massive debate about that, right? With the Cassini family in France.
Yeah, they thought the Earth was elongated, like an egg.
Which is wild to think about now. But it took the French Academy sending actual expeditions to Lapland up near the North Pole and down to Ecuador at the equator to finally settle it.
They went out, measured the curvature, and proved Newton was right. We definitely live on a squashed sphere.
But even calling it an oblate spheroid is kind of sugarcoating it, right? Because according to the gravity data, it's more like a potato.
The potato of Potsdam?
Yes! The potato of Potsdam. I love that visual. The geoid.
Right, the geoid is basically the shape the ocean surface would take if it just flowed freely through the continents, driven only by gravity and rotation.
Yeah. And since gravity varies depending on where mass is like a mountain range versus a deep ocean trench, the water level wouldn't be smooth, it'd be all bumpy.
Exactly. Hence the potato. And navigating that potato requires some incredibly sophisticated math, though humans have been clever about this for a long time.
Yeah, like Eratosthenes in 240 BC.
Oh yeah, estimating the Earth's circumference using shadows.
Just shadows in Alexandria and Syene. But
Okay.
Al-Biruni in the 11th century was the one that really stood out for me in these sources.
The lazy but brilliant approach.
Yes. Instead of walking for days across deserts to measure distance like Eratosthenes required, Al-Biruni just climbed a mountain in what's now Pakistan.
He just measured the angle of the dip to the horizon.
Right, and used simple trigonometry to calculate the radius of the Earth. Just so smart.
It was a stroke of genius.
Yeah.
He turned a massive planetary problem into a simple triangle. And it's that exact same drive for precision that actually gave us the metric system. Yeah, a lot of people don't know the meter was originally defined as 1/10,000,000th of the distance from the North Pole to the equator, going right through Paris.
So every time you use a meter stick, you're literally referencing the shape of the Earth itself.
Exactly.
And speaking of that level of exacting precision, that ties in perfectly to our sponsor today, Embersilk. Because just like geodesists need millimeter accuracy to map the world, businesses need absolute precision to integrate AI effectively.
Right. Embersilk specializes in AI training, automation, and software development. If you're trying to uncover exactly where AI agents can make the most impact for your business or even your personal life, you need a partner who really understands that nuance.
You definitely do. You can check them out at embersilk.com for your AI needs.
So, jumping back to the modern tech stack in our sources, we are way past mountains and shadows now.
Oh, yeah. We're using things like VLBI, very long baseline interferometry.
This is where it just gets incredibly cool. We're using radio telescopes to look at quasars.
Those super bright, ancient objects billions of light years away.
Right. They are so incredibly distant that, from our perspective, they don't move at all. They act like fixed lighthouses in the universe.
And the telescopes here on Earth just measure the tiny difference in the arrival time of the signals.
Like a cosmic stopwatch. By timing exactly when that radio signal hits different telescopes on different continents, we can track the Earth's orientation in space.
Down to a millimeter.
Down to a millimeter. And we have to do this because the Earth is constantly changing. Plate tectonics are literally shifting the continents.
And the length of a day actually varies because our rotation isn't perfectly smooth.
Exactly.
See, that's the part that really contextualizes the whole blue dot thing for me. Your GPS receiver has to account for the continents moving and that lumpy gravity field we talked about.
The geoid.
Right, the geoid. It needs all of that just to give you an accurate height and location.
Oh, yeah.
Without it, your map app is totally useless.
It is a complete marvel of physics, astronomy, and engineering working together. And the future is even brighter. The research points toward using optical clocks next.
Oh, the Einstein relativity stuff.
Yes. Einstein proved time moves faster the higher up you are away from Earth's gravity.
And these new optical clocks are getting so precise, they can actually detect the time dilation difference between your head and your feet.
Which means soon, we won't need to measure altitude by bouncing lasers off the ground. We'll measure height by checking how fast time is passing on an incredibly precise watch.
Measuring height by measuring time.
Exactly.
What an incredibly optimistic thought to end on. We've gone from measuring shadows in the dirt to literally measuring time itself to find our place in the universe. The things humanity can figure out are just endless.
We're pretty clever when we put our minds to it.
We really are. Well, if you enjoyed this deep dive into the invisible science of our world, please make sure to subscribe to Intellectually Curious.
And hey, leave us a 5-star review if you can. It really does help get the word out.
Huge thanks to Silk for sponsoring, and thanks to you for tuning in. Stay curious, everyone.